Okay, today let's talk about the Robby Machine's Wig Wag flippers. They actually are based off of pinball machine flippers, and pinball machines had only had solenoid-driven flippers for about 9 years before Robby was built. 1947, I believe, was the first time they had them. So they are, in fact, shaped a lot like flippers you'd see in a pinball machine, and they were, in fact, driven by a solenoid, same as you'd find in a pinball machine. Let's bring up this image. Here's an image of I'm going to make it bigger, of a solenoid that you can buy today, these days, 12 volt. And you see it has a spring that pulls this plunger out. When you apply the voltage here, the plunger gets sucked in so it can pull. When you turn the power off, the plunger pops back out again. And that's what was used to control the flippers in the Robby head. This piece of plastic represents some test parts when I was trying out different ideas. But as you can see, when this lever moves, if you had this connected to a solenoid, every time the solenoid would suck in, it could move and return. And because you've got two different points linked together, let's pretend the black tape are the flippers, so as they'd move, you would get this kind of action. And that's how the Robby worked in the movie. Now when it came to the Robby machine, I was faced with the dilemma of if I went ahead and put a solenoid in there for this machine, then there's going to have to be some sort of control to activate it. And I kind of wanted my machine just to be a standalone thing that you could turn on and it would just, sit and do its thing. And I didn't want to add electronics. I didn't want to have to go in and add a Pololu or some other programming device to sequence the flippers and sequence the valves and all that kind of stuff. I just wanted to be able to turn on and let it go. So I've gone with a mechanical connection between the cams that are controlling the sax valves and to move the flippers, just to keep things real simplified. It also saved the money of trying to buy and source, in case all you guys wanted to build them, that solenoid return, which can be expensive depending where you get it, and might even be hard to get in quantities, who knows. Well, now as I was stumbling through my pictures, I found this interesting picture. Try to bring it up here. This is an actual inside picture inside Robby the Robot's head. This isn't one I've taken. This was given to me by Bill Malone. See, inside original Robby head. And the front of the mouth area, the neon tubes would be down here. These large square things that you're seeing, those are actually the lamp holders for the automotive lights they had inside the sax valves to light them up. These large tubular things are like globe electric motors. Back in the 50s, you couldn't get small little motor assemblies. Everything was large and heavy heavy duty for that matter. If you look closely in the picture, you can see the rod across here, and you look real close, you can almost see some of the sax valve flipper cams that would spin around and hit it. In fact, this motor here was driving this shaft through a right angle gear arrangement right there. This motor up here is driving the top gyro section up in the dome at a right angle gear. And these ones sticking out were for the ear cups. Of course, this one would drive straight out. This one would have to go to a right angle gear to spin the antenna vertically. But it's an interesting picture. What you're seeing around this outside edge here, this is the aluminum frame, ball bearing frame. And this is wood. This whole red inside is the color of the ABS plastic that Robby was thermoformed in. We talked about that in the sax valve one where I showed you where the red was showing through in places. It isn't painted. That was the color of the plastic that was underneath. And those parts were glued on before Robby was painted. Okay, so you've seen roughly how the mechanics are going to work. Let's get back to a picture of showing you. These represent all of the parts that you would print to do the flipper assemblies. And I have all these parts on one little STL file on Thingiverse. So if you don't want to paint your flippers, you might want to print all the parts, since they print at one time, in white. And if you don't care if you paint them or not, then you can print them in any color you want. But basically, you're going to, the last thing you'll put on after everything is put into the head will be the flippers. That's the last thing you do. These little axles end up getting poked through. This is the inside. They get poked in from the backside through. And there's 2 screws and that linkage. It's different than this linkage, but it's the same setup. You've basically got 2 arms and the linkage, and they come through. So the first thing is those little pins go into the end of these arms. After they're shoved through, you're going to have to glue those on. There's no alignment necessary there. Then you'll put in this linkage part between the 2 arms. And then this piece is going to go on. There's a long screw that the slot interfaces into to form a pivot point. So here's your first step. I got the arms. I've got them glued to those pins. Got the linkage in place. So if I were to move this back and forth, these 2 arms would rock. These are simply stops to keep the arm mechanisms from going further than I want. This screw head sticking up isn't connected to anything except for this arm. It's just sticking up because the next piece that we're going to hook on here to pivot to here slots into that to move it. What we're going to do is change rotation in this direction to a thing that rotates in this direction. And there it is. So this arm, you can tighten the screws down. These are like number 2 self-tapping screws, and then back them off 1/4 to 1/2 a turn. You can see how it slots around that. So if this gets lifted, that's going to move this over this way, and if this drops down, it's going to push it over that way. This is going to get moved by one of the sax valve cams as it comes around. It's going to come around and hit this and push it up. And then when it gets past here, it's going to drop back down. So that's going to make the flippers move automatically whenever these sax valves are running. I actually ended up putting, you could glue a couple of pennies or a coin or something. I found an old nut or washer or something in my drawer, and I glued it on there as a counterweight. It worked fine without the counterweight. In other words, the weight of this plastic was heavy enough to pull everything down as the thing lifted, but I wanted a very quick, snappy action, so I put some weight right on top here. So now I'm showing it in the pushed up position, as if the cam had come around. It's going to push everything over the opposite way. See, we went from being over here with this down to being over here with this up. Then the whole assembly will get fed into the head and goes through from the inside. So your glue will be on this flat surface, and you'll shove it through the holes in the front of the head. You do want to make sure that you've drilled out the holes if they're not big enough for these to pass through. They should pass through, but if they don't, ream them or drill them, because that has to pass through without binding, without friction. Basically, this cam sitting right here is the one that's going to do the lifting and cause the action to occur. So you see how they pass through? You don't want them to rub, so when you glue it in place, make sure everything continues to move freely and doesn't rub. And then you could also take what's left of that shaft that's coming out there and give it a copper or some gold-colored brass or copper paint so everything kind of blends in together. It's like, say, the last thing you'll do is when you know that lever's down all the way, that's when this one should be straight over and this one should be straight down. You'll glue those on in those positions, so that when that lever gets lifted, this one drops, this one swings over. I think that's about the end of the show and tell. I've got, of course, the real thing sitting right here, as we can see. So you can see normally you can take it and you can move it, and it's just the weight of that lever pulling it back down again. So as this runs, every time that flipper comes around, it just hits that. And like I say, you don't have to do it that way. Anyway, let me run this for a second first. Like I say, you don't have to do it that way. You can buy a solenoid and you can build it up like the original movie one was done. Now in the 1950s, the solenoid was the only option they really had. These days, if you didn't want to use a solenoid and you didn't want to do this mechanical thing, you've got a lot of options. One, You could just go in there with small 9G servos behind each one of those and connect these on. They only move that 90 degrees. With a little servo going to whatever favorite kind of controller you like to use, could move those flippers real easy. Hell, a stepper motor. You'd have to write a program and get a driver for the little stepper motors, because they make little teeny stepper motors. You can put a stepper motor behind each one and then tell it to go 90 degrees and then travel back and forth, and you could do it that way. There's a lot of things you could do these days that they didn't have the options of doing back then. I mean, their options were coming down to motor driven, which would have been heavier and bulkier and more gears and cams, or a simple solenoid from a pinball machine, which at the time was still pretty much cutting edge technology. Like I say, the flippers on the pinball machines had only been around for about 9 years at that point. So I think that's going to wrap it up for the flippers, and I'll try to get the files up on Thingiverse. And like I say, it's actually one file. All the parts are in that one small file.